Good morning, sir. My immense pleasure on behalf of our department. I welcoming Mr. Maheswaran for our uh, short-term training program. He has completed BTech Mechanical Engineering in Pondicherry University and ME Computer Aided Design in Hindustan College of Engineering, Padur, affiliated to Anna University. And he has 13 years of teaching experience. In that, 10 years in Sri Venkateswara College of Engineering as assistant professor, and 3 years experience in AC Tech campus, Anna University, as teaching fellow. And he's currently doing his research in the topic of flow induced vibration. He has involved in consultancy work for industries like Weston Thompson and Nippon Thermostat, Tafe Limited, etc. And he has completed 5 consultancy projects which involves in CFD and a structural analysis domain, and he has experience in handling program orienting subjects like FEA, operation research, strength of materials, engineering mechanics, and KOM, kinematics of machinery, design of machine elements for both UG and PG. I'm welcoming you, sir. The session for you.
So thank you, sir. Thank you, Padra, sir. Thank you, Murugan, sir, as well as David, sir. So it's an immense pleasure for me to join this STTP program. So let me share my screen. Is the screen is visible, sir? Yeah. Thank you all. So today there will be a practical demo in by using a simple optimization and topology optimization. How to do this in ANSYS Workbench, right? Considering that as a basics, so we're going to start and work it out in ANSYS directly, and we are going to do two different types of problems related to simple type of optimization and topology optimization. So kindly bear with me. There may be a network issue. If there is an issue, something like that, I will join it. So by regulating it here. So let me consider a simple problem like this. So you have an optimization. So you have a simple beam. So which is having a T like a shape as shown here. So the length of the beam is around 3 meters, and it has a load of around 60 kilonewton per meter, uniformly distributed load. So we know usually we will be analyzing these types of beams, and we'll be identifying what is the stress developed in this. So in a better way, so let me consider, I'm going to consider this two dimensions, that is 225 mm dimension and 50 mm dimension, right? So what we are going to do is, first we are going to analyze this in an as usual way. After we analyze it, so we are going to optimize this. So what will be this value, an approximate value? What happens when it is increased, when it is greater than 225? Similarly, what happens if this is greater than 50 or lesser than 50? Right? So this is my constraints. So increasing it and decreasing it accordingly. So when you do something like that, what happens to the beam, and which will be the best optimized dimensions which we will get for this particular section? So this is what I'm going to plan. So we will be doing it in a workbench. So now I will share the other part of my screen. So what I'm going to do here is I'm going to consider ANSYS Workbench. So I have considered the latest version of ANSYS, which is downloaded from the ANSYS website. So you can go for ansys.com/en.in. So where you can able to see free trials or academic. When you click that, you have ANSYS free student version. So you can download it. So this is the ANSYS student version. By clicking this, you can able to download the software. So instead of 2021, so which is later released, so but I use 2020, so which I have downloaded in December. So I have for 1 year validity. So you can able to see the license duration here. So the license is it can be renewed. So it will be a 12-month lease license. The I think it is around uh, 6 or 5 GB. If you have a better internet connection, you can download this and you can use this education version for analyzing the softwares. So let me open ANSYS. So I have installed ANSYS here. So ANSYS 2020 R2, which is before this. There is no much difference between this latest version and this one. So only a little bit. So here I have something called as ANSYS Workbench. So at the bottom, you can able to see you have an ANSYS Workbench. So I'm right clicking this and I'm opening it as an run as administrator. So now let it opens. So you can install this. This workbench is a combination of all type of analysis. You can go if I consider a particular product, you can use that a particular product to analyze structural, CFD or thermal, electromagnetic. Even now it has they are implementing chemical and electrical also. We can also analyze these types of things in this particular module. So you have different a little bit modules in this, so where we can use that to analyze it. So now you can able to see here. So you have the screen here, workbench screen. So here you have a project schematic. So where you can put whatever the analysis you are going to put in this. And these are the analysis systems. There are it has some toolbox. Whichever analyze you can able to do that. So it is simplified and is kept as a particular module. So for example, if I want to go for structural analysis, you can able to see here static structural. You can just click and drag and drop it here. Or double click this. You have a system coupling and other things. So you can able to see these things. So there are lots of analysis systems available in this. So you can able to find out so whether the which part is a better one. So now in order to do that, so am I audible? Yes. Yeah. Yeah, thank you. So now what we are going to do is let us go for static analysis. Just double click this. So you may get a window here. So indicating what are the things you have to do in order to get the results. So first thing is engineering data. So this is where you can able to put the Young's models and other material data for your particular application. Just double click this. So usually default it will take structural steel. If you want to change it, you can also change it accordingly. You have an option here, engineering data sources. So there are commonly available data here. So by clicking this, you can able to get lots of data. So what type of material you want? For example, I want a composite material. You can click that. So in that composite material, you have another box here. What type of composite you want? So something like this, or any other analysis, general materials. When you click that, you can able to see here. So these are some general materials available here. So copper, aluminum alloy, and all the other materials also available. So whatever material we need, so you can just click a plus button, so indicating it will be added to your project, so that you can use that so when you are modeling it. So this is an option here, so to click this, and you also an option having an option here to just enter the data, right? So what we can do is we can go for the value here, so you can enter it here, right? So you can able to create your own material by choosing these things. So you have a particular toolbox here. So for example, physical properties, whatever you want, you can drag it out and you can just enter the values so that it will be added. So after we complete this part, we can close this. So you will get a tick mark, so indicating that you have already given a particular material. The next one is geometry. So when you go for a geometry, there are two different types of geometry things we can able to do in ANSYS. So previously we call that as a design modeler. So when I right click, you can able to see. So one is a design modeler. The other one, newly they have introduced this space claim. Right, the space claim is for other type of analysis where it is similar to a 3D software, 3D modeling software, where you can able to do all types of 3D analysis, and you can also um, uh, whatever fixing a particular geometry. We can do this. So because most of the time, what we will do is we will take a model from Creo or any 3D modeling software. We will be converting it to an IGS format. Then we'll be introducing the ANSYS. So when you do that, so sometimes the phases will be not good. So there may be some errors in some phases. Some edges will not be proper. So these things you can able to rectify it using this space claim. So they introduce that. So for the first analysis, I'm going to use a design modeler. So for the second analysis, that is topology optimization, so I'll be using that space claim so that we can have both some interaction, so how it works. So let me click this design modeler. You can also import your geometry from here. So by clicking this, whatever geometry, you can browse it and you can also import it. That also I will show it in the next demo. So let me click this design modeler. So usually, since I am doing it directly, so it may take some time, so for analysis and opening the software. So kindly tell me if I am a bit faster. Yeah, yeah, thank you, sir. So now you can able to see you have this design modeler now, so which is opened. So this is where I'm going to model my T section, so which is an inverted T section, right? To do that, so first thing is I have to fix this unit. You can able to see here the unit is in meter now. So but my T model is in mm. So what I'm going to do is I will go for units here, click and change it to mm. And you do that, automatically this will change, so that my image, whatever I am going to draw, will be fixing on that particular graphical window. So now let me select my XY plane. So to do my drawing, so this has to be kept in a what a perpendicular way. So you have a symbol here, right? So look at the face. You can click this, left click this, so you can able to see it has opened. It is showing it now in a 2D, right? So I'm rotating my mouse wheel to zoom in. So now what I can do is I have an option here. So modeling, and you have something called as sketching here. Let me go to sketch, and you have a line here, right? So let me click this line. I'll draw a line. So first click, and I move it. So H indicates it's horizontal. So I'll put it here. So similarly, I am doing this model here. So this is my model. So V indicates vertical line. So it will automatically align it as a vertical line. Yeah. So I have done a rough sketch. Now let me dimension this and I will make it in proper way. So let me go for dimension. So I'm going to introduce some horizontal dimensions. Let me click this. So from here to here, I have to give a dimension. Similarly, from here to here, in order to make it as a symmetry, I use this dimension. And similarly, this one, this web, right? And symmetry of this web, right? So whatever I have given, it shows in something in terms of H1, H2, H3, H4. So you have the data here, what is H1 value and H2 values and other data here, so that I can enter the value here, it will change automatically. According to this model, so it is 150 and and 50. So these are the horizontal dimensions I have. So when we go to the model, so H1 is 150 and H2 will be half of it, which is 75. H3 is again 50 and H4 is half of it, which is 25. So I have got a little bit a different model now. So now I am going for vertical dimensions. Let me fix my vertical dimensions. So vertical dimensions, I want this one and this one. So these are the two dimensions. So V5 and V6. So according to my problem, V5 is 50 and V6 is 225. So let me enter that value. So you have here V5 is 50 and this is 225. Yeah. So now when you zoom it, so a little bit still, I have some variations in this vertical dimensions. Let me give that vertical dimensions. So let me give from here to here. Sorry, it is already there. So yeah, it is already there. I want to give on this side. So let me go here. So let me give and this is V8. That is also 50. Yeah. So now I can able to get a proper T shape. So a completed T shape. So now what I can do is, so I can go to modeling now, right? So the XY plane, what I have drawn, I have a sketch that. So this is my sketch, right? So now I'm going to extrude it. So whatever we do in Creo, so the same part. But this simple optimization, it is not applicable when you import a particular geometry because it requires dimension. So that's why we are doing it directly here. So we'll go for this sketch. Let me click extrude. So it is for 3 meter. So let me click this geometry. So this is the geometry, sketch one geometry. And my extrusion is around 3000 in mm, right? So once I give this, so you can able to see a lightning symbol, which means you have to update this. So same lightning symbol you can able to see here as generate. Let me click this generate. So now it has been generated. So when I rotate my mouse, you can able to see. So my T section, so a beam is ready. Now, since I have completed all my part here, let me close this. Yeah. So now you can able to see your geometry is ticked out. So which means that it is completed. Okay. So now let me save this file. So because sometimes if it crashes, we need this file. So I will save it in some. Yeah. Now let me go for the next step. So the first two steps is over. The next step is modeling, so which means meshing your geometry. Let me double click this. Yeah, usually this one will take some time because it will import the geometry. Yeah. Now I got the geometry now. So you can able to see here. So you have a geometry, materials, and other things. So if I click my material, you can able to see there are two materials here, right? So one is copper alloy. You have all the data related to that. Another one is a structural steel, right? So these are the two data. For my geometry, so if I want to look at the properties, or let me click this particular analysis. So this analysis, you can able to see it's a static analysis. Sorry. Yeah. So let me click this particular geometry. You have the solid geometry. When you click this, below that, you can able to see what type of material we have assigned. So we have assigned a structural steel material here. So defaultly, this will be the usual one. So because structural steel will be a mild steel, which is the default one. So if you want to change, you can click this and you can change whatever we have imported in that engineering data. So I imported only these two material. The copper I have imported. So if I want to change, you can click this copper alloy so that this will be changed to that material. So this is one option here. So where you can able to change your material property. Now you have mesh here. So ANSYS is working a lot of researchers. They are doing lots of research and other things. So in order to get a proper mesh. So now in latest ANSYS, it will identify a geometry and it will mesh automatically so that it reduces our usual work. So just what I'm going to do is let me right click it and I'll go for generate mesh. So no need to worry about what type of mesh and other things. You can able to see. So it has done a very good meshing. So in older ANSYS, it won't be like this. So, but since they are upgrading it again and again, so you are getting a very good mesh here. And of course, if you want to increase the mesh, you can also do that by clicking this mesh. You have something called a sizing. In sizing, you have a resolution. 2 is the resolution here. If I increase my resolution to 4, and when I remesh it, right? So this will increase the number of meshes. So you can able to see previously it is somewhat lesser, now it is increased. So I can't go more than 6. I think for this particular I can go up to 7. I don't know whether 7 is will work or not, because since it's a education version, there are some constraints. So you can use only a particular type of amount of elements. So that is the thing. Okay, so in order to avoid lots of timing, I'm going to make it to 4. Right. So when I look after the model, so it shows that the two sides are fixed and you have a load at the middle part. So usually we'll be dealing with ANSYS APDL. So in APDL, we'll be generating key points, nodes, and elements. So if I want to give a particular value, force value or something like that, so we'll be using that. Um, what you can say, we'll be selecting the nodes to do that. But now in this case, you can able to select only the particular surfaces. So it is not applicable for node selection or element selection in ANSYS Workbench. So ANSYS Workbench is applicable by selecting faces, surfaces, something like that. So that is the one part here. So most of the analysis will be done in what I can say, something like if we want to put a bolt or something like that, we'll put a hole and we'll be selecting that surface hole for constraints. So now, in order to give this two ends fixed, I'll right click this, go to insert, fixed support. Let me click fixed support, select this particular surface. Right, I'm going to apply this. So this one end is fixed now. Similarly, there is another one on the other side. So let me go do that also. Right click, so insert, fixed support. Let me click this. Sorry. So when you move my cursor, so this is another thing. When I move my cursor, you can able to see your cursor changes. So to a particular value, we can able to see you have a cuboid. So now you are selecting a face. So when I move it a little bit, you can able to see. So you are selecting a edge now. So when I move here, you can able to see we will be selecting a corner. So actually corner is not possible in workbench. So while selection. So you can also do that in this part. So this is the part where you have a smart selection. We can select all the things. Or if you are keen in particular selection, for example, I want to select only face, can select this. Only say face will be highlighted. So you can't able to highlight the edges. So this is another way of selection. So let me select this one. I'll go for apply. So I have made two fixed supports. Next, I'm going to apply a load here. So instead of a UDL, I'm going to apply it as a force. So totally it is 3000 mm. So my force here is around 60 kilonewton per meter, which is for 3 meters. So 60 into 3, so 1800, right? Sorry, 180. So 180 kilonewton per meter. That will be the load. So I'm going to apply that as a force. So right click, insert. So you have force here. Let me go for a force. Let me click this, select this particular face, and make it apply. And you can able to see that it is highlighted in a yellow color. So this one is 180. So totally 180, but it is 10 power 3. So I put E3, indicates it is 10 power 3. So kilonewton, right? Let me click OK. So let me click enter. So you can able to see. So now you can able to see that the direction is wrong. So the direction is upward direction. Actually, it has to be downward direction. So you have below, you have something called as direction. Click this. You can change the direction by clicking this one arrow. So now you can able to see. So the direction is downward. Let me click apply. So now you can able to see it has been changed. So it's very simple. So we have completed this part. The next thing is solution. So where you are going to analyze what type of problem it is. I make right click. I want deformation, total deformation. Similarly, I want what is the total stress. Right? These are the two datas which is required for me. So what I can do, I can select these things. So now it shares again a lightning symbol indicating you have to update or solve. Let me click solve. So now you can able to see, you can get the results. So this is my result. So this is the usual way. So this is my deformation and this is my stress. This is the usual method of solving a statical uh, for a statical analysis. Any clarification till now? Yeah, I will proceed. Okay, I will proceed. Now, the next step, what we are going to do is we are going to go for this analysis. So, as we discussed here, I am going to optimize this 225/50. Let me consider. So, there is a range here. So, which is, let me change it from 30 to 50 or 30 to 70. Similarly, this also I will put a particular range. For this particular range, which will be a better way, right? This thing we will do that. So for that, so I need a particular value, so result value, which has to be used for a reference. So either it may be a deformation or a stress. So let me consider my stress. So I can able to see this is my detail of my stress. In this, you have maximum, average stress values. Let me consider maximum, right? So maximum, you are getting a stress of around 5.9. So you're getting a stress of around 5.9 into 10 power 7 Pascal, right? Which is around 59 megapascal, right? So you have a stress of around 59 megapascal, right? So my aim is my stress should be lesser than this. It should not be greater than this. So it should not cross 59, right? So in that case, I will consider this as my output, a reference feedback value. So you have a box here. Just click this box. It will change it to P, indicating it is parametric now. So which means you can change it will consider this as a reference value and it will analyze it accordingly. So now I will close this. So this part is over now. So by clicking this P, I'm closing this. So automatically you can able see there are some parameters set here which is changed. So, but it is not completed. Actually, this has to be completed with respect to this. It is not completed because I have an output. My output is my stress, but I have not specified any input now. So that is why it is showing like this. Now, let me open my geometry again. So let me right click this geometry. I will edit in Design Modeler again. Yeah, you got this model now. This is my sketch. So this sketch, right? So you can able to see, right? So all the data is here available. So what are the data? It is showing here. My concentration is on this V5 and V6, which is having 50 and 25. So I'm going to change this only these two values. I'm going to increase and decrease it accordingly so that I will get a better result in my stress. So what I'm going to do is these are my input data. This 50 and 225 is my input data. Again, you have a box here. You can click this box. So 50. So I'm going to give this as a name. Click OK. Similarly, this V6. This is also another part. So these are the two parameters which I'm going to use it. So I'm changing these two parameters, right? So I have completed this part also. Now let me close this. Yeah, now you can able to see. So you can able to see it forms a loop indicating that you have input and output. So with a parametric set, right? So now I can use this types things to analyze it. Let me double click this. When I double click, you can able to see there are some values here. So what are the values? So my V5, which is 50, and this is 225, and what is my stress value? These are my two input values. You can able to see which is available here in white color where you can edit it, right? So you can edit this and you can change this values. And this one is the output value, so which we can't able to edit, right? So if you are keen about particular value, for example, I have a doubt. So instead of 50, if it is 55 and this is 220, I feel that you have a higher stress. In that case, you can just enter the value here, right? So you can just enter, for example, instead of 50, let me put it as 55 here. And instead of 225, let me consider 220, right? So I am increasing here and I am decreasing here, 5 mm. So I am keen about this value. So I have a doubt. So this will have more good results. So I have a doubt that whether it has more lesser stress value. So I'm just entering the value and I can have an update design points. Let me click this. What happens is it again runs in background and it will give what is the result for that particular data what I have entered. So of course it takes some time for this analysis. Yeah, any clarification till now with respect to this? Yeah, you are getting that value. So what happens is when I increase this and decrease it, you can able to see it is having higher stress when compared to your previous value. So this is one way of finding out the value by just giving this value here and doing it. There is other way like doing it in by using some constraints and objective functions. So let me close this parametric set. So this is my set now. So now I will just minimize this analysis system, component system, and custom system. You have something called as design exploration, right? In this, you have something called as direct optimization. So I am analyzing it directly. So there are other options like Six Sigma analysis and other analysis also. So let me click this and drag it and put it here, right? I'm left clicking, dragging and put it on this particular set, parametric set. So now it creates a parametric set and is asking what is the optimization. So it shows a question mark here. Just double click this. Now it opens another window indicating what is my optimization, what is my constraints and other things. Let me click this optimization. So what type of method I am going to use here? You can able to see it here. So let me minimize this. So yeah, you can able to see here. So these are the different things it will consider in automatic. So I'm going to consider this as an automatic runs. So it will take 8 samples. Evaluation is 33. So number of candidate is which is best among three, right? It will show something like this, and you have other options here also. So by clicking this, okay, so you can able to get this information. The next one is objective constraint. When I click this, right, so you can able to see here there is a table here indicating what is my objective. So let me click my parameter. So my parameter is stress, right? So my objective is to minimize my stress, right? So what is my minimize value? If I consider my minimize value is um, it is 59 megapascal, right? So it should be lesser than 59 megapascal. So that is what I am giving as a minimization part. Okay, this is my first constraint, objective. Objective. It is not constraint. It is objective. So your output will be always an objective. The other one is I will go for your constraints. Let me go for the constraint. So this is V5. So V5 is that 50 mm, right? So instead of this objective, I will go for this part. Sorry. I think I have only one objective. Sorry, you don't need this one. I will delete this. I have only one objective. Yeah, this is my only one objective. So next is your input value has to be given here. So by clicking this value, you can able to see. So you have two input values here. So my lower bound, that is minimum, I should have 45 mm. Maximum, I can go for 60 mm. Let me consider. That means my vertical distance. This vertical distance, I'm concentrating from 40 to 60. Similarly, instead of 250, I can give what is my upper limit and lower limit, right? So this is 225, right? So I'll concentrate from 210 to 230, something like this. So these are the two values which I am entering. Based on this value, it will analyze, right? So it will take randomly, right? So it will take randomly and it will identify which is the best one, right? So just a minute. Yeah. So I'm going to change my optimization method. So usually it is automatic, right? So actually you can go for automatic to analyze it. What it will do it will take 33 iterations. We'll go for 33 iterations, which will take lots of time here. So in order to avoid that, so I'm changing to manual, right? Because I'm going to take only 5 points, so that I can do it only for that, or 3 points, not more than that, only three, because this alone it will take around 5 minutes of time. So that's why. So let me change it to manual, and I will change this to screening. So screening indicates how many samples you want. I want only three samples. Okay. This indicates that it will take only three values. It will automatically take randomly three values. If I give 100, it means it will take 100 iterations. It will do 100 iterations. It will identify the best value. Right. So I'm concentrated on three, and my candidate is instead of three, I will consider two. So just for difference, so what is the candidate? For that, I'm giving two. So instead of one. Okay. So these are my analysis settings, which we have done. So once I have completed all these things, what I'm going to do is I'm going to update it. Right. I may click update. So it shows the results. So the results, it takes only three values. It won't go more than that, because I have limited to three, right? My screening is three. If we go for automatic, it will take 33. It will run 33 and it will give, there are lots of different methods of identifying this optimization. It will take accordingly. So what is the best suited method for this particular analysis? It will take out like that. So you can try it out for uh, automatic, but since it will be a time consuming process, I'm going for this. Yeah, let it take some time. Before that, I will go for the next one. So next topic, we will discuss that. So then we'll go for that particular analysis. So the next optimization, we'll be discussing about topology optimization. So what is this topology optimization? I just given an example diagram. Let me consider you have an object here, which is having a constraints like this. So you have a constraint on this side and you have forces on the other side. So you can able to see this object is not looking pleasant. It is somewhat like this higher object, and of course the material and weight of this object is larger, right? So what we do is we analyze this. When you analyze it, you'll get a result. This result you can use for optimization. You can identify what are the unwanted material. You can reduce that unwanted material. You can compute it and you can interpret the result and you will get a new design. You can able to see the older design, so which is something like this. One factor is it is not looking pleasant. The other factor is it is taking lots of weight, material and other things. But when after analyzing, right, after analyzing, you are getting a new design field. Just a minute. Paper tuttalama. Okay, okay. Okay. Yeah. So the other one is this one. Hello. Hello. Can you able to hear me?
Yes, sir.
Yeah. Thank you. There's a
Why
connection.
is
Hello. So can I
Yes,
proceed,
sir.
sir?
Yes, sir. Yes, sir. Yes, sir. You can proceed, sir.
Sir. Sorry, I think there is a little bit connection problem.
Okay, sir. Okay, okay. No issues, sir.
Okay. Yeah. So let us consider this particular. I hope can you able to see the screen?
Yes,
Yes,
sir.
sir. We can.
Ah, okay. So I'm going to consider this as a simple bracket, something like this, which is used to mount a camera. So we will analyze this in topology. We will identify what will be the reduction in this particular structure. This is the commercial one which is available, but let us consider this as an example, and we will try to do that. Hope I think that analysis will done. Yeah, so according to this, I think, sorry. So when I click my optimization, you can able to see a tick mark here. Once the optimization is completed, so I'll get the results here, right? So we talked something about candidate points. So I mentioned two here, indicating that which is the best two results, right? So you can able to see that it gives some stars, 3 stars, indicating it is lesser when compared to the whatever value which is given, something like that. So when compared to the three iterations what I have given, it is compared with the three iterations. Don't think that. So because my optimization, I have reduced only for three, right? So I've taken only three samples. But if you increase the samples to 50 or 30, you will get better results, very accurate results in this, right? So this candidate point will indicate in terms of 3 star, 2 star, and 1 star, indicating which is the better material, sorry, dimensions, which is suitable based on your constraints. Hope this is the way of simple optimization. Any clarification in this regarding this particular?
No, sir, it's clear.
Okay, sir. Now let me proceed with the other optimization, that is topology optimization. This one. So for this, instead of drawing these things, I have done this in Creo. Right. So let me open that. Let me close this. So I don't want. This is the bracket. You can able to see here. Yeah. Okay. Right. So it has this 3, 4 bolts, and you have the two mount. Right. So this is the thing. So what we have done is I have just converted this to. I have made a save as a copy, and I have changed this to a parasolid model. So according to Creo, so parasolid is more compatible in ANSYS. So that's why I'm converting to parasolid, and I have saved it. So I kept it in desktop, right? So I'm going to use that, right? So in ANSYS. Okay, let me close this. So now same thing. So I'm going for a static analysis, static structural. Either you can click and drag here or double click this. So I'm not going to concentrate on any engineering data. Actually, it will take a structural stream. I will consider that alone. Here, I will right click it and I will import my geometry. Right? I will browse my geometry. So I have the same geometry here. So in the parasolid model, I will select that. So even though you got a tick mark here, so let me double click this. Just a minute. Yeah, sorry. Yeah, I am double click this and it is opening. Now space claim is opening. So as we discussed earlier, so previously we talked about this design modeler. Now we deal with this space claim. Yeah, the same thing is opened here in the space claim. You can able to see the model here. So once I complete that topology, we will try to fix some errors, a little bit of errors in this particular model. Just shown it for a purpose. That's it. Let me close this. Yeah, so you can able to see it has taken the geometry in space climb, and you can able to get a tick sign here. Now the next thing is my model. Let me double click this model. The procedure is same as we had done for static analysis. So still static analysis, same procedure. After we complete static analysis, we will go for topology optimization. Yeah, it takes some time. Yeah, I got that bracket. Yeah. Okay, I got that bracket. So now I'm going to mesh this. Right. My sizing, I will make it to 3, not more than that because it takes lots of meshing. It's a tetrahedral mesh. So when you do that, it increases the licensing. That's why I'm reducing it. So this is the mesh what we got. So based on this, I think I can increase one more. I think it will work. Let me try. Okay. So I got this mesh. So you can able to see there are lots of tetrahedral meshes. So now what we will do is we will go for constraints. When we go for right click this, we go for insert, and we go for fixed support. So I'm going to fix all this holes. So where we are putting some bolts, so to hold it. So I'll select this one. Sorry, I'll choose this face. I'll select this face, the upper face. I'm holding control. I'm pressing the other one. Yeah, I will complete this one first. So you have 4 faces. Similarly, right click, insert, another fixed support. So this one and the other one. Similarly, by holding control, I'm clicking these faces. These are my fixed supports. Next, this hole is having, this 2 holes is having a force of around 30 kg. So assuming it, so let me go for force, selecting this two and this two, and click OK, apply. So when you look here, so by using this one, I can apply the force. I need force which is it has to be acting towards downward direction. We can able to see here, which is Z indicating downward, indicating that it is a positive. Positive direction is towards downward. So negative is towards upward. So you can able to move your cursor and you can able to see. So this one is minus Z. Upward is minus Z, plus Z. So whenever you give a plus value, it indicates the direction will be towards downward. So I will change this define vector to component. So my component is this Z coordinate. So where I am going to enter the value. So 30 kg, approximately 300 Newton. So 300 Newton. I may apply it. Sorry, 300. Let me apply this and press enter. So positive values, as I indicate, it's showing downward direction. So you can able to see an arrow here, a small arrow indicating downward direction. So these are my forces. So I applied force and the values. So now I will go for this particular thing. I will go for stress and deformation. I may run this. Now you can able to get the results. So what is the stress developed and what is your deformation? When you look at the stress, you can able to see here there are yeah. So there are lots of blue color indicating which is having a lesser stress when compared to this one, this part, right? So what the software, the in topology, what it happens is it identifies the stresses which is having, which is whichever is blue color, it will try to neglect that stresses by removing that material. So most of these elements will be removed. Slowly it will remove and it will reduce the part accordingly, so that we will get a better um, lesser object, right? So once I have analyzed this, let me close this. So that's it. This part is over. So let me save this file. Now the next step is I'm going to connect with topology optimization. So there are two ways. So when you click this, when I click and drag it, it shows something like this. You can able to see some green boxes. When I put in a particular green box, it means it is not connected. So this is not connected with your previous box, which means we have to do again the geometry model and other things, and you have to analyze it. This is one way. The other way is I'm deleting this. Yeah. So other way is when I click this and drag it, it shows a green color. Let me put it near this solution. You can able to see here. So which means it will take your this model and it will link with that. So let me put it here. So I can able to see. So you can able to see that your engineering data, your geometry, your model, that is your mesh model, and even the solution has been linked and it has been connected. Right. So now what we can do is we can just double click this setup. Yeah, now you can able to see there are new features here, which is topology optimization features. Were indicating so what are the regions which you want to include and other things. So wherever you apply the load, that will be excluded region, so which will not be reduced. So that is very important. And you have some response considered as 50%, so you can change these things. So what we can do is just click on a particular, here also you can give some objective functions, whether you want to minimize your stress or whatever it is. And constraints, when you go for response constraint, so percentage to retain. So how many mass, response is mass, you can change this. Whether you want to reduce the volume, mass, center of gravity, whatever it is, you can choose it accordingly. So I am going to choose mass. So I concentrate that I want to retain 60% of your overall product. So which means I am going to reduce 40% of the mass. So specify the values in this particular response constraint, right? Once you complete this, you can also give some restrictions. For example, I don't want to reduce this part, for example. Really important in having this part, something like that. You can specify that also, right? So I'm not going to do that. Let us do it directly, right? So once I have completed these things, so only one data I entered. What is the percentage of um, mass which I am going to retain, and whether it's a mass or other things. These are the only data I entered in this topology, right? So others I am not going to change anything. Just I'm going to solve this. When I solve this, you have a tracker here in solution information indicating how the structure is reducing, right? It will show lots of iterations. So what are the analysis it is doing it, and finally we will get to a conclusion. So this is the real model, and now it will reduce slowly. So it takes some iterations and identifies the best suited results. Yeah. So it has completed. Now you can able to see that. So you can able to see there are lots of materials which is removed. So without affecting the stress value, right? That is what. So you can able to see here. So there is a reduction in this particular material. So lots of reduction, and this is the new material design, which we can use it for this particular camera bracket, right? So without affecting the stress values. So how to do these things? Now we got this results. How to change these things? That we can do it here by just closing this. You can able to see all are ticked here. Now I'm going to transfer this to geometry. The result has to be transferred to the geometry. Right click this, you have transferred to geometry. Right, model is again I am analyzing this for a thermal or other type of analysis, something like that. I'm going for a geometry. I may click this transfer to geometry. So once I do that, it will again ask to give me some, sorry, to update it. After that updation, you can able to open it in that space model. So any clarification till now? Okay, sir. Thank. Ah, yes, sir. Yes, sir. Yes, sir. Yeah, you can able to see here. You have some option here, so which has to be updated again. I will update this. Usually in 3D also, in 3D modeling also, we have this option of changing it, as Sam told. But we can't, we won't analyze it based on stresses. I think we'll be doing it directly. I think this one is a part with this involving with some stress values. That's it. That's the only difference. Yeah, I have to update both result and geometry. Then only I can able to open this. Yeah, let me open this now. Yeah. Now we can able to see the geometry. Both the geometries are available, old geometry and the new geometry. So let me uncheck this so that the old geometry will go off, and you have only this new geometry now. So this is now in phase, that is in elements. So you have to convert it to again geometry. Right click this, convert this to a solid with merge phases. Let me do that. So now you can able to see that most of the outside object has been merged. So this side, this is one way. If you have a real version in the college, you can go for file, save a copy, save as, and you can go to, you can convert it to some other model. That is again, so you can change it to Cataya part or Parasolid model or IGS format, so that you can open that in 3D modeling software, and you can change whatever the dimensions accordingly based on this particular value. But now it is not possible because it is restricting with some phases. So even if I try, I think it says that 300 phases. Since it's an education version, it is not allowing more than that. So only thing is I have to update these things by using this fill option. you have an option here. Just click this fill, select a particular sets of thing, and I just click a tick. It will convert it automatically. So you can able to see here. So this is one option where you can able to edit these things. So whatever you want, you are concentrating on, right? So something like this, so that I will get a clear images, so a little bit clear faces. So you can able to do something like this in all the faces. Something you also have an option here. You have something called as repair in this, so where you can able to see some merged faces. You can click this, right? You can click a particular set of faces and you can click merge face and then click OK. So it will convert it accordingly. Yeah, you can able to see. Yeah, it's somewhat a smoother one surface. So this is one way of doing this, converting most of the part, and then later we can make sure we can able to uh, model it again, right? So there is other way is like what we do in 3D modeling software, same thing. I can trace this curve, whatever which is at the top. You can trace this and they can able to do that. Okay, so that also possible. So in Sketch, you have an option. You can click this and you can go for a plan view. And here you have an option here. So project to Sketch. By clicking this, so I need a body outline. Select a particular body, so you can able to see here. So it will create these things, right? So this is one way so of doing your slowly we have to do that, so to convert it to a real solid model, right? So of course it's a time consuming process, but slowly we can able to do that and we can able to get a new design, so which without affecting the particular model, right? So this is how we can able to optimize it in this particular method, right? So I also have another example. So you can able to see there is this another example, a bracket, so which is having some hole and a similar type a bracket on it. I also tried with a chart, but it is not coming it properly. So this one I have a model. I will let me open and show you how this will be. There's another model of a similar that example what I have shown in this thing. So you have a hole with a 10 kilonewton force. You have a rectangular bracket. So fixing on these two sides and you are applying a force tangentially. So for that, you got this result. So after we analyze it. Yeah. So this is the model. So after we do that topology analysis, so this model, which is this one, so this is converted to this one, right? So which is having reducing the lots of areas. Thereby, we can redesign this to a new model with same stress values. Uh, so I hope it is the demo is somewhat clear and it's good. Thank you for Panimalar Institute so for giving me an opportunity for this particular program. Thank you, sir. So any other queries in this regarding this? Thank you, sir.
Thank you, Maheswaran.
Sir, thank you, sir.
Thank you for your wonderful demo. I think we have to work on workbench, ANSYS workbench a lot. I think there are so many modules are there. Okay, so you have given an exposure for our participants. Thank you, sir.
Thank you, sir.
Thank you.
Yes.
A part.